Welcome back to the channel. This week's video will be the collision repair process on a Tesla Model 3 where we will be replacing the left quarter panel and outer wheelhouse. The C-pillar reinforcement and upper wheelhouse reinforcement will also be getting replaced as this is required as per the OEM replacement procedure for the outer wheelhouse. The process to remove the quarter panel begins by grinding down the spot welds and SPRs using a belt sander with 80 grit. Next, the wheelhouse hem flange is removed with a grinder with an 80 grit disc. If you're interested in learning more about the collision repair process on Teslas, hit that subscribe button in the upper right hand corner for new weekly content. The three sectioning locations are now cut using a cutoff wheel and a mini cutoff wheel. These sections are being cut 2 to 3 inches below the final sectioning locations as labeled rough cuts, so we are able to overlap our new panel and accurately cut our final sectioning locations. This will be highlighted later in the video. A seam buster and hammer are now used to separate the panel. In areas with structural adhesive, the panel is warmed up to help release the structural adhesive before using the seam buster. The quarter panel is now removed, showing the extent of damage to the outer wheelhouse. The C-pillar reinforcement and the upper wheelhouse reinforcement are going to be required to be replaced to change the wheelhouse as per the OEM procedure. We will now start removing the C-pillar reinforcement. The spot welds and SPRs are ground down using a belt sander with 80 grit before warming up the panel to help release the structural adhesive. The striker area is double layered, so the first layer is ground down and separated. The flange is then folded upward and the second layer is ground down with the belt sander before removing the panel with a seam buster. The upper wheelhouse reinforcement is now removed by grinding down the spot welds with a belt sander using 80 grit, warming up the structural adhesive, and separating the panel with a seam buster. With the C-pillar and upper wheelhouse reinforcement removed, we now have access to remove the outer wheelhouse. The spot welds are ground down with a belt sander, and one spot weld is drilled out with a 6.7 mil drill bit as the outer wheelhouse is layered between two non-damaged panels. The panel is then warmed up to help release the structural glue before separating the wheelhouse from the vehicle with a seam buster and hammer. With everything cut apart, we will now clamp the new outer wheelhouse to the vehicle to perform a test fit. None of the structural adhesive has been cleaned off yet, so we are able to line up the new wheelhouse on all the old marks. We now start drilling all our rivet locations as the new outer wheelhouse will be rivet bonded to the vehicle following the OEM replacement procedure. There will be 3 different types of rivets used, which includes 4.8mm structural rivets, 4.8mm countersunk rivets, and 6.5mm structural rivets. The countersunk rivets are used from the backside so the rivet head sits flush to the panel because the high voltage cables and wiring sit directly behind these rivets. A paint pen is now used to mark all the areas to clean for structural adhesive. The wheelhouse is then removed and prepped for the application of structural adhesive. Structural adhesive is now spread on both sides with an additional bead applied to one side before installing the wheelhouse. The wheelhouse is then clamped into place with the rivets placed in the prepped holes. The rivets are then compressed with the Express 800 rivet gun. The structural adhesive is left to dry for 24 hours and the clamps are removed from the outer wheelhouse. Next, the upper wheelhouse reinforcement is clamped into place and the holes are drilled for the 12 6.5mm rivets. With all the holes drilled for the upper wheelhouse reinforcement, we now clamp the C-pillar reinforcement to the vehicle. We start drilling holes for the 4.8mm structural rivets, punching holes with the Express 800 rivet gun for the SO8 and S18 flow form rivets, and drilling the one hole for the 6.5mm structural rivet. A paint pen is now used to map out all the areas to prep for structural adhesive. Both pieces are now removed and the upper wheelhouse reinforcement is prepped. Structural adhesive is spread on both sides with an additional bead applied to one side. The part is then clamped into place and the Express 800 rivet gun is used to compress the 12 6.5mm structural rivets. The C-pillar reinforcement is now prepped. Structural adhesive is then applied and spread on both sides before applying one additional bead. The part is clamped into place and the Express 800 rivet gun is used to compress all the 4.8mm, 6.5mm, and flow form rivets. The structural adhesive is now left to dry for 24 hours before removing all the vice grips. Any squeezed out structural adhesive is now cleaned off using an angle grinder and a belt sander with a Scotch-Brite belt. All the inners are then scuffed with a red Scotch-Brite and painted using tan and gray to match the original appearance. The new quarter panel is now test fitted on the vehicle, overlapping it on the sectioning locations that were cut on the rough cut lines. The rear door and trunk lid are now test fit, confirming proper gaps before cutting the sectioning locations. After confirming proper fitment, the rear door is now removed and the sectioning locations are cut with a mini cutoff wheel and a hacksaw. The quarter panel is now taken off and the 3 rough cut sections the quarter panel overlapped are removed. The inners of the quarter panel are now scuffed and sprayed, matching the original quarter appearance. The Express 800 rivet gun is now used to punch the backside of the SPRs that were ground off when removing the quarter panel. We'll be replacing these with flow-form rivets when installing the quarter panel. 2 flat dies on the rivet gun are then used to flatten the panel before test fitting the quarter panel. Both doors, the trunk, and the rear bumper cover are all now test fit to confirm proper fitment of the panels to the new quarter panel. The vehicle is now taken apart and all the rivet and weld locations are mapped out using a paint pen. We start punching all the holes for the flow-form rivets using the Express 800 rivet gun. There will be 4 different types of flow-form rivets: SO8, S18, S28, and S38. These rivets are different lengths depending on how many layers that the rivet is going through. Afterwards, the holes for the 4.8mm structural rivets are drilled. Now the sectioning and spot weld locations are prepped to bare steel. 1 plug weld is drilled underneath the rear upper sectioning location. The quarter panel is now removed off the vehicle and the plug weld locations are drilled on the trunk gutter flange. Afterwards, the quarter panel is prepped for structural adhesive 2 ways, either cleaning the panel to bare metal or scuffing the areas with a Scotch-Brite. Areas where steel bonds to steel will be cleaned to bare metal, and areas where the steel quarter panel bonds to aluminum inners will be scuffed. The plug weld locations have weld-through primer sprayed on the backside, but unfortunately while prepping the vehicle's mating flanges, I had a technical issue while filming. The C-pillar foam is now reinstalled, and additional expanding foam is squeezed into the backside. Structural adhesive is now spread on all mating flanges with an additional bead applied to one side. Sealer is then applied to the charge port area and the C-pillar foam. The quarter panel is now clamped into place with all the rivets put into the prepped holes. The quarter panel has a small amount of adjustment in the lower rocker area, so the rear door is test fit one additional time to confirm proper fitment. All the flow form rivets and 4.8mm structural rivets are compressed with the Express 800 rivet gun, followed by rolling over the Wheelhouse hen flange with a rubber dolly and a hammer. The resistance spot welds are now completed. The rear door is removed before welding up the sectioning locations. As per the OEM replacement procedure, welding is performed once the structural adhesive is fully dry. The sectioning locations are open butt joints with the mating flanges filled with structural adhesive, and the upper rear sectioning location is completely filled with structural adhesive. The weld is now ground down using a belt sander, cutoff wheel, and a grinder with an 80 grit disc. The area is now prepped for body filler, feather edging the repair area with 180 grit on a 3-inch sander. The plug weld is now welded below the rear section, and any squeezed out structural adhesive is cleaned off using a belt sander with a Scotch-Brite belt. The area is now completely prepped for body filler. The wheel arch is now sanded down using a dual action sander with 80 grit. Next, the lower sectioning location is welded. The area is tack welded before performing small stitch welds. All of these welding clips have been edited together as the weld was performed in multiple stages to limit any warpage from too much heat. With the weld completed, any squeezed out structural adhesive is cleaned off and the weld is ground down using a belt sander, cutoff wheel, and an angle grinder with an 80 grit disc. The panel is then prepped for body filler, feather edging the repair area with 120 grit with a dual action sander and a mini 3-inch sander. Body filler is now spread on the lower section using a spreader and a 3-inch brush. I use a brush for inners with multiple body lines as it spreads easier, making the sanding process quicker. The trunk is then lowered, confirming the proper fitment, followed by removing the trunk and hinges to weld the plug welds in the trunk gutter. The welds are then ground down and the area is prepped for body filler. The lower rear section is sanded with 80 grit before using powdered guide coat and switching to 120 grit. Body filler is now spread on both upper sectioning locations and the trunk gutter. Afterwards, all the areas are sanded, starting with 80 grit, switching to 120 grit after using powdered guide coat. All the repair areas are then feather edged with 180 grit on a dual action sander, prepping for the application of finishing glazing putty. Glazing putty is now spread on all the sectioning locations and the trunk gutter. The upper sectioning locations and the trunk gutter are all now sanded, starting with 120 grit, switching to 180 grit after using powdered guide coat. The repairs are finished, feather edging with 180 grit on a mini dual action sander. Body filler is now spread on the wheel arch where there was a small amount of damage from folding over the hem flange. The lower rear sectioning location is now sanded with 120 grit, switching to 180 grit after using powdered guide coat. The powdered guide coat helps show any imperfections such as high and low spots and sanding scratches. A dual action sander is then used to feather edge the repair area with 180 grit. The body filler in the wheel arch is now sanded. A skim coat of glazing putty is applied and the repair area is sanded and finished feather edging with 180 grit on a dual action sander. .440 Pinhole Express is now wiped on all the repair areas and this vehicle is ready for the paint shop. The vehicle is now back from the paint shop and we start the assembly process with the front door being installed. Next, the end panel has all the bumper retainers bolted on, the wiring reconnected, and the weather strip installed. The rear door is now hung on the vehicle and the door handle and closeout panel are installed. The rest of the door will be installed later as we need to adjust the rear door glass. 3M cavity wax is now sprayed on the backside of all the repairs as a rust prevention measure. The rocker cover and quarter liner are then installed, followed by the rear wheel being torqued to spec and the wheel cover attached. The charge port door is now installed. The high voltage system has been disabled and high voltage gloves are being worn when bolting the charge port unit back to the charge port area. Next, the trunk and hinges are installed back on the vehicle from the underside with the 6 13mm nuts. Afterwards, all the components are installed back on the trunk to complete the trunk assembly process. Some interior components are installed, followed by bolting the rear door striker to the body to confirm proper fitment of the rear door. The glass is then installed with the inner and outer belt molding. The glass will be adjusted after the quarter glass is installed to confirm proper gaps with the quarter glass and the B-pillar applique. The rear bumper cover and taillights are now installed. This vehicle is now ready for the glass department to install the quarter glass. With the quarter glass installed, we now screw the body side molding back to the vehicle and install both the front and rear body weather strips and B-pillar applique. Next, we adjust the rear door glass to confirm even gaps on both sides of the door glass before installing the rear door trim panel, completing the rear door assembly process. The vehicle is now water tested to confirm no leaks are present. Afterwards, all the interior components and rear seats are installed. The vehicle is now completed and ready for the detail department. Thanks for watching, and don't forget to subscribe for new Tesla content every week.